Okay, year 11, I'm going to make a video about exercise 404 and the sorts of things that are involved here and the many different ways you can solve some questions. So usually what you'll have is you'll have all these examples before they do the exercise. And again, what we're doing here is we're doing linear functions. Now, you should be able to graph linear functions, but the new stuff for you, or the stuff that's going to be different, is all this real life type of equations that you're going to need to draw and understand. Usually in mathematics, in old past papers, most of the work has been algebraic and strictly in the Cartesian number plane. But now we're talking about relating it to business, finance, statistical versions, and I think that's going to be the common content that you're going to come across in the HSC with general standard maths. So the first thing we need to understand about these linear functions are the two forms, and they're here. And you'll notice that the new thing here is you might have seen the gradient form of y equals mx plus b, and they've changed the letter to a c. It's just a polynomial. But that's a gradient intercept form where that is the gradient. The gradient, and that is the y-intercept. And that's the most useful form. And we can do that on our calculator. So remember, on your calculator, you can use the statistics function. So if I go to my setup and I put on the stat function, the delay. So if I go here and I hit the stat function and look at those numbers there, the first one, number one variable, gives you all the statistical information. The rest of them are regression forms, which relate whatever data you're putting in to a type of regression. Now, the very first one is a linear regression, but they've written it in a form that's different from the one that we've got, where they've written a plus bx. Well, the a in that case is your y-intercept, and your b is your gradient. And we'll have a go at some of them later, but that's the regression form that you need if you want to talk about linear regression and relate it to some of these things here. It'll also give you the equation of a straight line if you put in 2 points, which will become handy later. The other form is this form, and that's a general form, and it's a standard way that they tend to write equations, but it's not very useful. The a, the b, and the c don't really tell you anything. They're just pronumerals or constants that will come in for your linear equations, but you need to be able to write them in that form. And finally, this other here, this direct variation. Now, direct variation is what we use to describe a linear relationship. So if two variables, and we use x and y because they're from the Cartesian number plane, are in direct proportion or vary directly with each other, that means usually as one goes up, the other goes up, which is what they say here. Here's direct variation. As one goes up, the other goes up. As one variable increases, so does the other. But we know linear equations can go up and down. So some examples of direct variation. Some examples of direct variation would be, okay, you're driving a car and you have distance and you have time, and you start at home and you travel away and you're traveling at a constant rate. Oh, that'll be the speed. Okay. And so your distance equals some constant times your time. And that that rate becomes the speed. So if you're traveling at 50 kilometers an hour, and we know that that varies and it's not always a straight line, but that's direct variation. As the the distance goes up, the time goes up. Or as the time goes up, the distance goes up. Well, and that's just a straight linear relationship. We can have another one that's similar to that. So like a taxi, the time in the taxi with the cost of the taxi. Well, when you hire a taxi, you get a call out fee. So as soon as you get in the taxi, you've already got this. They call it the flag call, because if you watch any of those movies in America, a little flag would come up, and that's what you pay as soon as you get in. Doesn't matter if you go, if you don't go anywhere, you've still got to pay that call out fee. And then the longer you're in the taxi, the more the taxi rate goes over, and that's called. There you go. You get another equation. So the cost will equal some constant times the t, and that'll be the rate, and there are different rates, but you also get plus this amount over here, whatever it happens to be. I'll just call it F, the flag call out fee. And remember that this K is the rate of the taxi fare, so the fare rate. Did I spell that correctly? I'm pretty sure I did. Now, there are all sorts of other situations you can do. You could do the cost of getting a plumber to come out, and again, the plumber will have a call out fee, and then they'll have the plumber's rate $1 per hour, and all sorts of different things. But when we talk about linear equations, they can also go down. So please understand that direct variation is as one goes up, the other goes up. All right? But we can have things go down. So go back to that car one. Imagine if you this time said, oh, okay, the fuel consumption with the distance, or the amount of fuel in your tank. So you might start off with a tank, and it might be, I don't know, 60 litres. And then the more you travel, the fuel in your tank goes down until you get to zero and you've reached a distance that's your maximum fuel capacity. And that rate is your rate of fuel economy. And that's written on, when you go and look at any car, that I'll say how many kilometres per litre, and or that might, and you can work out your fuel economy rate. You notice the way I'm saying rate quite a lot, because rate is the gradient. So they're the two new things. All right, this linear function stuff, the y-intercept form and the general form, you will have seen those before. But the words direct variation, and they're in the syllabus, and direct proportion relate to, and have a look at here, this y equals constant, where k is the proportionality constant. Okay, so let's have a look at some of the questions. And there's one there. There's Huang's $20 per hour, and the income versus the number of hours, which is a nice, easy, direct proportion. Now, let's have a go at some of these questions. Oh, no, the other new thing, we have interval notation, but we've already talked about interval notation. Remember, if it's included, if the point is included, you'd use a square bracket. So, for example, if I draw a parabola here, and I draw the domain and range. So this is y equals x squared. Now, the range goes from 0 to infinity. But we don't include infinity because you can't plot infinity. So we have a curved parentheses there, or parentheses, whereas we have a bracket at 0 because it can equal 0. The domain, so that's a range, and we'll just use an R, the domain of that function, y equals x squared, well, it can go anywhere on the real number system, which is from infinity negative infinity to infinity. And that's all real numbers. All real numbers. Most linear functions are all real numbers, unless they're a horizontal or vertical line. Okay, so here we go. And you can see there, there's the line y equals 2, and the domain in negative infinity to, it can be any real number, but the range, it'll always be equal to 2. Okay, so let's go and have a go at some of these other questions. So the first one, and it's a good way to think about these, the number of months in X years. So I always say, oh, okay, start off with 1. How many months? So the number of months in, how many months in 1 year? Oh, 12 times 1. Yeah? How many months in 2 years? Oh, 24. Now think about it, 12 times 2. Right? How many in 3 years? 12 times 3. Well, then how many in X years? Well, that's okay. You've worked it out now. 12x. Do the same for the other one. The amount of juice in a 2-litre bottle. So the amount of juice, okay, in one bottle, 2 times 1. In 2 bottles, 2 times 2. In 3 bottles, 2 times 3. In n bottles, 2 times n. So you get this sort of idea. You should be able to do the rest of those. Find the equation and draw a graph of the cost of X refrigerators if each refrigerator costs $850. Okay, so the cost is going to be, well, 1 refrigerator, 850 times 1. 2 refrigerators, 850 times 2. 3 refrigerators, 850 times 3. X refrigerators, 850 times X. And to draw this, and I'm not going to draw it to scale, so here's the cost, here's the number of refrigerators. No refrigerators, no cost. And it's just going to be going up. And on this scale, 1, and here, 850, 2, 850 plus 850 is 1,700. Okay? And there's your graph of the cost. It's a direct relationship, direct variation. Find the x and y intercepts. So to find the x and y intercepts, if they're in the y-intercept form, it's really easy to find the y-intercept, but to find the x int, you let y equals 0, and to find the y int, you let x equals 0. So I'm only going to do a couple of these. So the first one, here's question 3a, and I've got y equals x minus 2. Well, usually if I let x equal 0, so I let x equal 0, well then y equals 0 minus 2 are negative 2. And that's the y int, y-intercept. And if I let y equals 0, I get 0 equals x minus 2, and I take the 2 over, x equals 2. And that's the x-intercept. Now you really should go through the process. You're going to use that a lot more. If I go down to I, because I is a little different, I'll do f. F has got an f of x. Well, remember that f of x just stands for your y. F of x equals 10x minus 5. Now I know it's obvious that that's the y int. We know that because it's in y int form. But I'm going to go through the process of it so you can see. So I'm going to let x equals 0 and f of x equals 0 minus 5, which equals negative 5. And that's the y int. And if I let y equals 0, or f of x equals 0, remember f of x, oh geez, that's bad. I'm getting more untidy as I go along. F of x equals 0, I get 0 equals 10x minus 5. I take the 5 over, 10x equals 5, and I divide by 10, I get 5 on 10 equals x, which is a half equals x, and that's the x-intercept. And if I do I, which is, I think it's 3x, x minus y plus 3, x minus y plus 3 equals 0. Well, I'll let x equals 0. Be careful here. I get 0 minus y plus 3 equals 0. I'll take the y over, and I get 3 equals y. That's the y int. And if I let y equal 0, I get x minus 0 plus 3 equals 0. X plus 3 equals 0. I'll take the 3 over the other side. X equals negative 3. And that's the x int. Okay, so the x and y intercept, just let x and y equal 0. So, domain and range. Drawing the graphs of those functions. Now, there's all sorts of ways that you can draw the graphs. You can use the y-intercept form, which is how I think you should be able to do it. You can plot 2 points. You can do all sorts of things. So I'm just going to erase a bit of this so that I can do these. And you should be pretty good at graphing these by now, after all your work in junior secondary. So you can always plot points. You can plot points. So I'm going to do that first. And you need to use a ruler when you plot these points, and a proper scale. Whereas if you do them just using the y-intercept form, you don't need to do that. So let's plot some points for the first one, and then we'll just do it the other way, which is the way I recommend doing it. So here we go. Here's 4a. And I've got the equation y equals x plus 4. So usually I pick 3 points, because if you make a mistake, you'll quickly see it. And I always pick -1, 0, and 1. Always pick those. And notice that I'm going down. Most of the other textbooks go horizontal. So now I'm going to just put them in. So if I put -1 in for x, I'm going to get -1 plus 4. And -1 plus 4 is 3, so the y is 3. If I put in 0, I'm going to get 0 plus 4. Oh, and that's 4. And if I put in 1, I'm going to get 1 plus 4, and that's 5. And then all of a sudden, I've got my coordinates written as coordinates, the x and the y. And then all I do over here is I draw myself a number plane, and this is not going to be accurate because I'm not using a ruler. Now you need to use a ruler. So what have I got? -1, and 3. I'll try and make 2, 3. So about there. And I've got 0 and 4. Oh, sorry, -1 and 3. How ridiculous is that? I'm going to need to extend this. So I'm just going to erase that, and we'll make that way up here. And now I'm going -1 and 3. 1, 2, 3, 4, 5, 6. So -1 and 3 there. Oh, jeez, what am I doing? -1 and 3 is there. 0 and 4 there. And 1 and 5 there. And your straight line, now if you've done it accurately, you'll get this point and you'll be able to measure it off. All right? So I haven't done all that accurately, but I reckon it's going to be, oh, look at that. I reckon it's going to be at -4. And because I haven't done a really good scale, it's, yeah. But you need to label that point and you need to find this value. Oh, but Mr. Tonkin, didn't we just do finding the x-intercept and the y-intercept? Oh, okay, so let's just let y equals 0, and I get 0 equals x plus 4, and I take the 4 over the other side, negative 4 equals x. And you go, yes, so it is negative 4. And that's how I would have done it originally. I would have plotted the y-intercept, which I can see very quickly. I would have let y equals 0, and I just would have drawn the line. So let's have a go at doing it that way with b. I've got y equals 3x plus 9. So y equals 3x plus 9. So, come on. So y equals 3x plus 9. Y equals 3x plus 9. Well, I'm just going to draw a small version of this. And as long as I'm pretty close to scale, I'll be all right. So plus 9 is my y-intercept. There it is. 3x is pretty steep. So this is a steep line. So it's going to go like that. And I have to find this value. Oh, let x equal 0. Let y equal 0. And I get 0 equals 3x plus 9. I take the 9 over the other side. 3x equals negative 9, divide by the 3, negative 3 equals x. And as long as you're pretty close to scale, and that looks pretty good, you're right. And that's the equation of that line. The other way to think about it, if it's written in this form, to find the x-intercept, change the sign of that, negative 9, look over here, negative 9, and divide by that. There. That's what you're doing. If you change if it's written in the form y equals mx plus c, you change the sign of that and divide by the thing in the coefficient of x. All right, let's do one that's not written the way we like it. Oh, I graphed the wrong one. I graphed this one up here. Well, that's okay, it doesn't matter. Would have done the same here with this one. I want to graph this one because I think it's the only negative one there. So x plus y equals 2. All right, so x plus y equals 2. So I need to write it as y equals. So I'm going to minus that x because the y always has to be positive. So this is d. Y equals minus x. I take a minus x plus 2 because I want it written that way. So I'm minus x from both sides. Now, what am I going to do? I'm going to draw myself a little number plane. I'm going to plot what I need to, and I'm going, oh, right, so it goes through positive 2. It has a negative gradient, so it's going down, and that's a 1. And that means it's going down at about 45 degrees. So I'm going to go like that. Now all I have to do is find that point. Now I can go through the process of going, let y equal 0. And if I let y equal 0, I could do it in the original equation. I'm going to, if I remember, look over here, if I let that equal 0, that'll just become 0. I'll get x equals 2. But if I'm using this equation, I change the sign of that, negative 2, and divide by that, negative 1. Oh, that gives me 2. Now remember, you can always plot points. If you ever get in trouble, you can always plot points. But really, you should be good enough to do this method here. Okay. And let's do the domain and range. So the domain and range of those three functions that we've just drawn, all three, the domain, well, they can be all real numbers, and the range is they can be all real numbers. They can go from negative infinity to infinity. But let's have a look at one that will not. So let's have a look at C, 5C. And 5C is x equals negative 5. Is that right? Negative 4. Well, you can graph it. Here it is. X equals -4 is just a straight line there through -4. There's my y and my x. Put arrows there. Okay. Well, the domain, tend to always write the domain first, the x1. Well, x only ever equals -4, and that's it. The range is all real values. It can go from -infinity to infinity. Now, to do 7, I want you to get, you should be at, so 4, 5, 6 are easy. 7, I want you to go away and have a go at it. I'm going to do it, all right? And then, but you need to go away and have a go first. So while I'm erasing, you go away. Okay, so you've had a go at it. You've come back now because you paused the video. You don't actually have to take the time out because you're a smart person. That's what you're doing in advanced maths. Now, let's read this question, because this is how I think the common content is going to come at you from the standard course. So what have we got? A supermarket has boxes containing dog food. The number of cans of dog food is directly proportional to, that means it's going up at a constant rate. To the number of boxes. If there are 144 cans in 4 boxes, well, first of all, let's write an equation. And they've given us the variables, n and x boxes. So n equals some number, k, times x, because they're in direct proportion. And we use k because k is a constant. Once we find it, it's never going to change for this circumstance. So the number of boxes is some number times x, and that number is going to be the number in one box. Right? Because if you've got 1 box, you'll have that number of cans. If you've got 2, you'll have that number of cans times 2. If you have 3, it'll be if we've got x, it'll be that number of cans times x. So what do? Well, we can just substitute the values in. So in 4 boxes, so when n equals 4, we have 144. Sorry, we have, when n, there are a number of cans, 144, we have 4 boxes. Remember, we've got to find k. Oh, well, that's easy. I'll just divide by the 4. So divide by the 4 and I get k. K goes into, what's that, 70, goes into that twice, remainder 2. Just do my calculator so I don't stuff it up. 144 divided by 4. I think it's 36. What am I doing? 36. 36. Once we've got that, that never changes. So 36 is k, and for this scenario, that will never change. It's a constant. Okay, how many cans in 28 boxes? Well, that's easy, 36 times 28. Okay, so n equals 36 times 28. So that's A, that's B, and what do we get? 1008. How many needed for 612 cans of dog food? I'll see. 612 is 36x. I've got to divide by the 36. So 612 divided by 36. 17 boxes. And that's how I reckon they're going to ask you this question. They might tell you other things. For question 8, to do this, and this is the one I'm worried about, you need to do that by plotting points and using graph paper, or using a scale and making sure your scale is right on. So I'm going to do it on Desmos, and that's the other good thing you need to do. You need to be able to use technology to do this. So what are the equations? You can write them as y equals, but Desmos lets you write them the other way. So we've got x minus y minus 4. So let's go to Desmos. And we'll just type in x minus y minus 4, wasn't it, the first one? Come on. Why does it say that? X minus y minus 4, x minus y minus 4 equals 0. There's the first one. All right. And let's go back. It was 2x plus 3y minus 3. 2x plus 3y minus 3. 2x plus 3y minus 3 equals 0. Now, if you did this accurately, you would get those two lines, and this is the point that you want, and it would be 3, negative 1. But you can see that if you do it freehand you might not get it. You need to be accurate with your drawing. So plotting points or using the intercept form, but making sure that you've got a nice neat grid paper, you use a ruler, and the point of intersection is there, 3 minus 1. You could check that by solving the two equations simultaneously, but I'm not going to do that now. I want you to go and finish the rest of the questions in that exercise.